working version of the banquet problem. And on the bottom, there are square tables and people. We can also use the tools on the writing tools to make a T-chart, if that will be helpful for you. And I can set that up for us. But we have to figure out what we're going to put in it. So... there.
Well, on one side, we should have the number of people, and maybe P.
Okay. So can somebody write a P on one side?
Yeah.
Okay. And then what would be on the other side?
A T for tables.
A T. Okay.
Oh.
Somebody can write it there. There we go. Okay. So on the other page, we started off with one table. So can somebody fill in the chart for what it would look like for one table and how many people can sit there? Let's see if we can do that. What would it look like in our chart?
Oh wait, it's other way around.
Oh, I'm sorry.
Yeah, you got the right number. It's just.
I'm sorry.
But that brings up the question. Would it be easier to put T on the left and P on the right? Would it make more sense for us to switch our chart? What do you guys think?
That's why I did my chart.
So do you guys agree? Do you want to switch T and P on the chart?
Sure, let's switch.
Okay. And that's sort of interesting. That's how we look at the variable. So we can talk about a dependent variable and an independent variable, seeing the relationship between those two. So T and P, tables and people.
I'm sorry, I was just looking at my T-chart, what I did on my paper.
Oh, no, then that's fine. And we're just going to transfer that to this. So if you want to continue filling in the chart based on what you had, we can keep going.
Who, me?
Or whoever did the T-chart, if you want to keep filling it in, and see if we can get to 31. I'll figure out which table would have 32 people, and then start to figure out the rule.
Maybe if you did the pictures as well, it would help.
Okay. So here, I'll put together the first picture, and then you guys can help me continue it. And you can move what I've already put. So this would be, I'm going to construct table number 1. Okay.
And then could we just add another table to this one?
Yeah.
Like,
so
move this person up here.
Mm-hmm. And that confirms what we put on the T-chart, that 2 tables is 6 people. Okay. So let's see what happens if we keep going with the tables. And we may not be able to get all 32 people around the tables, but at least we can start to see what patterns are developing.
Does anyone else want to do tables?
And I can do a couple of more. And then once we do a couple more tables, let's look and see what's going on here. So we can go until we hit the end of the wall. Okay, we have 6 tables. All right, so does anybody want to talk about when we're doing the tables or these T-charts, what's changing each time we add a new table? What changes? You can either talk about it visually, you can talk about how many people are added. Let's think about what's changing.
Well, every time you add a table, you add 2 additional people.
2 additional people. And is there something that's staying? So what's also staying the same? So we're adding 2 people with each table.
Right.
Okay. So, and then we're adding it to what we started with, which was 4. There were 4 people at the first table?
Right.
Okay. So we're adding 2 each time. And how... Somebody raising their hand? Oh, in the other room. Add 2 people. So then how would we write a rule? How would we write the rule for this banquet problem?
My problem was I came up with a rule to find the number of people you would have if you had a certain number of tables, but I couldn't figure out how to reverse it to find out how many tables we would need if we had a certain amount of people.
So let's put that question out there. Can you write out the rule that you came up with, and let's see if we can figure out how to make it go backwards.
So what I was thinking was the number of tables you had times 2 plus 2 equals the number of people you could sit around those tables.
Okay.
So I could be off.
So where does the plus 2 come from in your rule? Because that's really important.
Well, when I looked at the T chart, you had to add 2. You know, our pattern was we just kept adding 2 to the person side. This is the problem I always have. I don't know how to say what I did, but
Can I suggest something?
then just
Sure.
yeah.
Well, if you look at it visually, when you have, I don't know how to move these, but I think
Just click on them with the arrows.
you have. Am I doing this right?
Mm-hmm. Yep.
Yeah. So when you have one table, you have the 4, right?
Mm-hmm.
And then when you add another table, you still have the 4, but you have then space for those 2 more in between. Does that make sense?
So you moved the table over and added another 2.
Sort of like this guy slides down. He's still on the end.
Mm-hmm.
He was on the end over here when there was just 1, right?
Mm-hmm.
So he sort of slides down and makes room for the table to come in.
And then the tables get
That makes
squished. The tables get squished together, so you lose
So
lose
you
that
lose
space
that.
in the middle.
Yeah. I don't know if that helps to think of it that way.
So the +2 visually is
Are these
two
2 guys
people.
right here?
Is the 2
Yeah.
people sitting on the edges of the table.
Yeah,
Gotcha.
of the new table.
So is
Okay.
everybody in agreement that our rule could be tables times 2 plus 2 equals the number of people that can sit around that table?
Yes.
Okay.
Tables times 2 plus 2 equals the number of people. I don't see it.
So here,
No, it's tables times 2 plus 2, Teresa.
Yeah.
If you multiply the amount of tables that you have by 2 and then add 2, then you will be able to tell how many people you can have sit around those tables.
Multiply the number of tables by 2 and then add 2
Yes.
equals the number of people.
Yes.
Wow. I don't see it, but I believe it. I believe you're right. I just don't see why we multiply the number of tables by 2.
It was just the angle that I went in at. If you look at your T chart, okay, if we have 4 tables, this is that we have 8 people.
Right.
For 4 tables, I can sit 10 people. Here, let me move these. Let me see if I'm right. So for 4 tables, I have 8 on either side and 2 on the ends. So that's 10 people. I multiply the amount of tables by 2, and then I added 2 more people.
So each table gets 2.
Right.
So that's why you multiply that by 2. So there's 4 tables. If you didn't have these guys, if you weren't using the ends, you'd only have 8 people.
Right. That's
right?
why. Right.
If there were 5, you'd only have 10. So if you weren't using the ends, it would just be double.
Right. And then you are using the ends in this, so we're adding 2.
That's the 2 that you're adding on the end.
Right. Actually, I didn't even look at it with pictures. I just did the T-chart and came up with it that way.
and that's
Right,
valid.
but if you wanted to,
Yeah.
that is valid. And then, but if you need to, I don't know who wasn't seeing it. Who was that wasn't seeing it?
I'm not seeing it. So when you did the T chart, you came up with the same thing. T2 plus 2 equals P.
So who is that? Teresa?
Yeah.
Are you the one that's having a hard time with why you double it? And
Yeah.
okay, do you see that if there's 5 tables, there's 10